Our given topic is mixing and flow problems. Now, the problem states that there is a 100 meter cubic tank of water which contains a pollutant Z at the concentrations of 0.5 gram per meter cube. Cleaner water with the pollutant concentrations of 0.1 gram per meter cube is pumped into the well-mixed tank at a rate of 4 meter cubic per second. Water flows out of the tank through an overflow valve at the same rate as it is pumped in. The question asks to determine the amount and concentrations of pollutant in the tank as a function of time and then graph the result. Next, at what time will be the concentrations be 0.3 gram per meter cube, and at what time the concentrations be at 0.2 gram per meter cube. From the diagram shown, we can see that there is a 100 meter cubic tank full of water with a pollutant at 0.5 gram per meter cube, and at the above, cleaner water is pumped into the tank at a rate of 4 meter cubic per second, and the cleaner water have a pollutant of 0.1 gram per meter cube. The water that was pumped out from the tank also have the same rate as it is pumped in, which is 4 meter cube per second. Before we start, we must understand the basic formula mixture of two solutions. So, concentrations as a function of time given as dy over dt is equals to rate in minus rate out, whereas yt is the amount of substance dissolved in the liquid. Dy over dt is equals to rate at which yt is changing in the tank. Rate in is rate at which yt is entering the tank, whereas rate out is rate at which yt is leaving the tank. Step 1. We must calculate the value for rate in and rate out, and then substitute it into the formula of dy dt equals to rate in minus rate out. So for rate in, 0.1 gram per meter cubic multiplied by 4 meter cube per second is equals to 0.4 gram per second, whereas the rate out is equals to yt gram per 100 meter cubic multiplied by 4 meter cube over 1 second is equals to yt gram per 25 second. So, after we have found the value for rate in and rate out, we will substitute the value into the formula, and we will have dy over dt is equals to 0.4 gram per second minus yt gram per 25 second. And we will calculate the formula, and we will have dy over 10 minus y equals to 1 over 25 dt. From this point on, we will integrate both sides. So we will integrate dy over 10 minus y equals to integrate of 1 over 25 dt. Next, step 3, we will firstly integrate the left side of the equation, which is integrations of dy over 10 minus y. So, by using substitutions formula, we will let u equals to 10 minus y, and we will differentiate u, whereas du over dy equals to negative 1 and dy equals to negative du over 1. So, integrations of dy over 10 minus y is equals to negative integrate 1 over u multiplied by du over 1, and the answer we will get negative log u to the base of e. Now we will substitute the value of 10 minus y into u. We will get negative log 10 minus y base e. Now for step 4. After we have integrated the left side of the equation, we will integrate the right side of the equation, which is integrations of 1 over 25 dt, and the answer is t over 25 plus c. So combining the left side and the right side of the equation, we will have negative log 10 minus y base e equals to t over 25 plus c. Next, we will solve the equation by firstly moving the negative from the left side to the right side, and we will remove the log base e by multiply the whole equations by exponential e. So we will get the answer 10 minus y equals to exponential negative t over 25 minus c. Whereas the end of the equation, we will get y equals to 10 minus 1 over c exponential negative t over 25. And then we will get the answer 10 minus y equals to exponential negative t over 25 minus c. Whereas to solve the rest of the equation, we will get the answer, which is y equals to 10 minus 1 over c exponential negative t over 25. For step 5, we will find the value of C. We have known that the concentration Y at time 0 is equals to 50. Therefore, by substitution of the value, we will get 50 equals to 10 minus 1 over C exponential negative 0 over 25. So, by calculating the equation, we will get the value of C, which is negative 1 over 40. So, by substitution of C equals to negative 1 over 40 into Y equals to 10 minus 1 over C exponential negative T over 25, we will get the answer Y equals to 10 plus 40 exponential negative T over 25.
Question A. Plotting graph of amount and concentration. To find amount, use the function y equals 10 plus 40 exponent negative t over 25. To find concentration, use the formula concentration equals to amount over volume, whereby volume equals to 100 meter cube. Question B. Find T when concentration is 0.3 and 0.2. Given the volume is 100 meter cube. For 0.3, by using the formula of concentration equals the amount over volume, we get amount 30 gram. Then substitute y equals to 30 gram into the function of y equals to 10 plus 40 exponent negative t over 25. We get t equals to 17 seconds. For 0.2, by using the formula of concentration equals the amount over volume, we get amount 20 gram. Then substitute y equals to 20 into the function of y equals to 10 plus 40 exponent negative t over 25. We get t equals to 34 seconds.